For today's work, I'm going to start out by adding a GFCI to the outlets near the kitchen sink. So there are two outlets near the kitchen sink within 6 feet, so that they need the GFCI per code. You don't have to have a GFCI on every single outlet, it's just they have to be GFCI protected. So I'm going to start off by taking off the covers so that I could kill power and test which outlet gets power first and which one feeds off of it. For the GFCI to work, you install the GFCI outlet at the first location that receives the power, and then you connect the wires that supply voltage to the downstream outlets. And as long as the GFCI is wired correctly, then all of them are GFCI protected. Here I'm just testing power because I already killed power at the breaker box. So here I'm disconnecting the wires, or attempting to, without destroying the outlets. These are the old stab-in types from the 80, and this is an early 80 build or late 70s. So in order to find which one has power, you have to completely disconnect the wires from them, then turn voltage back on, and then just do a quick voltage test to see which wire is the only wire with voltage. Basically, you have to destroy these outlets in order to remove the wires. As brittle as this plastic is, it's impossible to remove it without the whole thing shattering. Now I'm turning power back on at the breaker box. Now I'm just doing a quick voltage test. So this far outlet has power. It's the only outlet with one wire with power. So I know this is the first outlet to receive the voltage in this circuit. So this is the location where the GFCI will be connected. Now I'm turning power back off, and I'm going to install a new outlet at this location and the actual GFCI on this right side. So these GFCIs have to be wired a certain way. The one side will say line and one side will say load. So I'm going to grab the wire that I know had voltage here. It's the one of the black wires. I'm going to put it on the line connection. And it's also important to put it on the right side. So typically there are two different colored screws on the left or right side. The brass colored screw is for the hot wire, and the silver colored is for the neutral wire. The hot wire or black wire is the one carrying the voltage, and the white or neutral wire is the return line. So once I have the line wires connected, I'm going to attach the load wires, which are the wires going to all the other circuits past this point. And I'm going to put them on the locations that are actually labeled load on the GFCI, and there's a warning here, a little sticker that tells you that it has to be wired correctly or they are not GFCI protected. Now I'm going to turn power back on just to do a quick test. I'm going to check with the voltage meter, make sure everything is wired correctly. The hot wires are all hot. Make sure the downstream outlet also has power. Then I connect my outlet tester to it, and this will tell me if it's wired correctly and if I could trip the GFCI. So there's a button on here where I just press it and it'll trip the GFCI if everything is correct. And I'm going to do the same thing at the actual GFCI outlet. It looks like everything is good. Now I'm going to kill power and finish putting them back into the wall. So I'm going to put some electrical tape around the screws just so they're protected, reduce the chance of accidental shorts anywhere. And tuck the wires back into place, make sure all the connections are tight. Put the outlet cover back on and then turn power back on. And do one final check, everything's good. This next part, I'm going to do a cleaning on the condensate line. There's a P-trap here on all these condensate lines, and this is typically where a clog happens. All the dirt and debris will collect here, as well as like mold and mildew and stuff, and it'll clog it up, algae type stuff. So I'm going to put a little snake line through it and just clean it out. And I'm going to pour some bleach directly into the line, and this specific location I have to put it in and then turn it back so that it flows back inside the drip pan for the evaporator coil. After I put the bleach down both sides, I'm going to put some flush water in. So on this location again, since I can't access the inside, I'm going to have to put flushing water in the emergency secondary drain, which can either drain outside or in this case has a cutoff switch, so that if it does get a clog in the main line, it'll overflow into the second line and kill the trip the switch and kill the unit. So I'm just putting it directly into the second line, and it's making its way back out the main line to flush out the bleach and all the debris I dislodged. And it's all flowing out the drain correctly, I can see it. Then I'm going to put everything back up and do a quick check on the filter. Tenants are notorious for never changing the filter, so it's always best to just change it yourself if you're at the location. And lastly, I'm going to do a clean on the condenser coil outside, get all the dirt and debris off it so it functions more efficiently. So I'm going to start off by just rinsing it with water, get all the loose dirt and debris off of it. These old Linux units are easy to clean because all the coils are completely exposed, all the fins. Next I'm going to put my condenser coil cleaner on it. I make this solution with some concentrate, and you just increase the amount of soap in it depending on how dirty it is. This one isn't that dirty, so I just mixed it about medium strength, and I'm just going to spray it and then let it sit for about 5 minutes. And if it's really dirty, you'll see a bunch of dirt running off the bottom. After letting it sit for 5 minutes, then I'm just going to do a quick rinse off and really watch all the dirt come out the bottom. And after everything's rinsed, that's all you need to do. Thanks for watching.